What's up, guys? My name is Michael Lin. Welcome to my YouTube channel. Today we're gonna do Upsolve Codeforces round 656 Division 3. So normally I don't actually do two live streams a day because I don't have that much time, but I am changing my schedule to now doing live streams and now at this time. So it's like 11 o'clock Eastern time. I'm gonna start doing live streams. All right, changing my time to 11 o'clock Eastern time, doing live streams. And yeah, that's what I'm gonna do now. In India time, I think that's 8:30ish. Let's see, what time is it right now? What time is it now in India? 9 p.m. ish. Okay, that's what it is. Okay, but anyway, we're gonna do. I realize that throughout the past times, I've actually haven't been upsolving any problems lately. So normally I just do a contest and then just whatever happens, whatever happens. You know, sometimes I solve 3 problems, sometimes I solve one, sometimes I solve two, and then my ranking is just wavering around that point. And I'm not actually improving at all. So at least I'm actually doing problems. That's a good part. The first step is actually just doing problems. So if you're too lazy to do problems, then you have to get that first. Start doing contests. Okay. Now it's the part to actually improve it, and to improve, you actually have to start upsolving. So yeah, today we're gonna do Codeforces round 656 Division 3, and we're gonna start upsolving these problems. So I solved the first 3 problems, and I didn't solve the rest. So I'm gonna do D and then try to do E after that. Okay, let me just push the live chat to pop up. So then if anyone wants to, so I could pretty much I use this so that I could respond to anyone in the group chat. So if you guys want to hit me a message in the group chat, in the live stream chat, I'll respond. All right, guys. Anyhow, so let's do this. So this problem is a good string. I've actually never seen this problem before. So yeah, this is actually a good start for me because at least I'm solving it right now with you guys. All right, you're given a string S of characters 1 to n. Okay, they're all lowercase. Okay, we're guaranteed that it's a multiple of 2, so 2 to the k. So we're guaranteed that the size is a multiple of 2, so it's even. The string S is good if there's at least one of the 3 conditions. So at least one of these 3 conditions means it's good. If the size is 1, it's only one character. The character is any character C. If the length of S is greater than 1, so if the size is greater than 1, the first half contains only C, and the second half is second half of the string. The rest of it is a C plus 1 good string. So, okay. So I guess it's like recursive. I guess it's defining this like recursively. So the first part contains. So the first half is going to contain only letters of C, right? A character C. It could be any character. C, it just repeated first half. The second half is second half of the string is a C plus 1 good string. So that means I'm not so sure what this means, but C is a good string if there's at least one of the following conditions. So the second half of the string is also a good string. That's what I'm guessing what they're doing, what they mean. Okay. Okay. Or if S is greater than 1, the second half of the string only contains the letter C, and the first half of the string is a C plus 1 good string. So that's recursively defined that as well. Okay. Okay, so this is a good example. AABC is a good string. AABC is a good string. So the first half of the string is all A's. So that's why it satisfies this condition, right? Then BC is the second half of the string. So the second half of the string is this, and it is a C plus 1 good string. So what does that mean? What does it mean by C plus 1 good string? So BC is a good, I'm guessing BC is a good string, I guess. Like it's by itself is a good string. I feel like there's something that has to do with divide and conquer. I don't know. I'm not sure yet. Because divide and conquer is like when you cut things in half and then you try to recursively call things on 2 sides. It's kind of like what merge sort is. Okay. FFGH. Okay, so this is following the third the third case, which is the first half is C plus one good string, and then the rest of the half is all E's. Okay, so that's one. Okay, so now we get those definitions right. In one move, you could choose one index from the string and replace it with any lowercase Latin letter. Any lowercase Latin letter from A to Z. Okay, so you can replace it with any lowercase Latin letter. Your task is to find the minimum number of moves required to obtain a good string from S. C good string for C equals A. It is guaranteed that there's always one exists. Okay. So we need to find the minimum number of moves it takes to obtain a good string from S. So I'm guessing S is not a good string currently. Okay. You have to answer T independent test cases. So we have to answer those T independent test cases. Let's look at this. Good example of a good string is as follows. So this is a good string, because the second half, because all A's. Okay, that's I understand that. The first half is a B good string. Why is it a B good string? Because the second half contains only the character B. Okay. And the first half of the string is CD is a good string because the first half of the string contains the letter C and D is a D good string. Oh, okay. I get it. So I think I'm starting to get what they mean. So I think we have to do divide and conquer. What now? Damn it, I just looked at the problem tags. Okay. Okay, did not mean to do that. It says divide and conquer in the problem tags. Okay, then it says bit masking, which I don't get why we have to use bit masking. I never understand how to use bit masking in these problems, by the way. But it is what it is. What language you use? You could choose whatever language you want. Generally, people use C++ because it's faster, but whatever language you're more comfortable with, it's a good idea to do competitive programming with, right? There's some people who do it in Python, even though it's slower. Because they're good, they're comfortable with doing Python. They're able to optimize their code to make it pretty fast. So it really depends on you. Okay, there's no language specific that you should do. Okay. Let's see. Okay. So let's do this. Okay, I'm going to. Yeah. Okay. Okay. I hope you guys could hear me. Actually, I'm not sure if you could hear my live stream. Okay, I'm not sure. Can you guys hear me in the chat? Okay, whatever. If the audio's not working, then I'll just delete the live stream in the video afterwards. But yeah. Okay. So now let's go back to this problem. Let's take this out. Let's take out the previous code out. I still don't understand about the factorial inverse from the last live stream. I have to look into that because that's kind of crazy. Okay, so we're gonna read in T, which is the number of test cases, and then we're gonna do while T minus minus. That's what we're gonna do. Okay, and then what are we gonna do? We're going to, let's see. First line is T. Second line is the integer n, and then the length of s. So that's the length of the string, and then third line is it's a string. Okay. So we are going to do read in n, which is the length of the string, and then read in s, which is the string. So let's do n and then string s. Okay. So that does that. Now what are we gonna do? We should try to figure out how to do this. Okay, so we could replace the following good string. Okay. Do we know if the string is already good? Okay. So if the string is already good, then we don't need to do anything. So yeah, so we have to check if the string is already good, then we just have 0. If it's not good, then we should let's think about that for later. Okay, I'm actually gonna put a timer on in case if this goes on too long. If I can't solve this problem in like 30 minutes, then I'm just gonna look at the editorial, because at that point, I don't know. because you should exhaust all possibilities before you do anything. Okay. Okay. So let's check if it's a good string already. So to check if it's a good string, the first half has to be all. Either all the characters are the same, or the second half is a good string. So let's do that. So let's do. Let's have a function called is good. So is good. Let's take in the string. Okay. So if the first half is so to do the first half, I have to actually substring from 0 to s dot size over 2, I think, and we have to make sure they're all the same letter. So to do that, we have to check if oh boy, can I do a dot count? No, I don't have a count. Okay, this is gonna be tough. Okay, let's first look at substring, because I know in C++ substring is based on position, the number of characters. So we have to, so if I have 8 and then I'm dividing by 2, that'll be 4. So I'm going to substring from 0 to, so let's look at this problem. So let's say I have, I'm gonna zoom in a bit. BBDC, so I have 8. If I'm going to substring, check the first half of the string, then I have to do substring from 0 to 1, 2, 3, 4, 5. Wait, 1, 2, 3, 4. I think it would be 4. It would be this. Actually, let's do a quick see out just in case if for our sanity purposes. So for sanity purposes, let's just do a cout. Let's create a string bbdcaaaa and then do dot substring. Actually, no, you can't do that. Let's create any string bbdcaaaa, and let's just do cout v dot substring 0 to v dot size over 2. Let's just see what this prints out. Because if it prints out BBDC, then that's fine. What's the errors? Come on, tell me the errors. What is the errors? Nope. Is good should return a value. Okay. For now, let's just return 0. We're not even dealing with is good right now. We're just checking if the substring works, because I don't remember that much about substrings. Okay, should give us BBDC. Okay, so that's right. Then let's check the right part. So let's do the same thing, but then we're gonna check from the right side. So let's substring from v dot size over 2, and then to the end. So let's. I think you could just leave out the position for that. Let's see what that gives us. So that should give us a. Yeah. Okay. So that's right. Okay. So now what we're gonna do is is good. We're gonna separate it into 2 halves. So we're gonna do like first part is gonna be s dot substring 0 s dot size over 2, and then the second half is going to equal s dot size over 2. Okay, so that's going to split it into 2 halves. Now we need to check if the first one is a repeated character. Then we're going to recursively call is good on the second part. And then if the second part is a good character, we're going to recursively call on the first part. Like, do you guys get what I'm doing? Right? That'll help us check if it's is good or not. I hope you guys understand what I'm doing. Because like if we're... Because in here, you're doing a string is good if the first half of the string has all the repeated characters, and then the second half of the string is also a good string, right? And so we could recursively call on that. So yeah, if it keeps going, and if one of them is false, then we'll just return like false. Yeah, and then we'll use like and. We'll and all of the values together. Yeah. Okay, so is good. So right now we have the first string is string is good if the first string is BBDC and then AAAA. Okay, so now we need to check if it's a repeated character over and over again, right? So that could occur in either string, either the first part or the second part. So like the first part, if I'm repeating a character over and over again, then in the first part, in this case, right, BBDC, the first part is not repeating a character that many number of times, but the second part is repeating a character, so AAAA. So what we're doing is that we need to check if the second, we got to check both parts, see if it's repeating the same character. To do that, we'll just do a for loop to go through it, and then just check if it's the same character. So yeah, to do that, we'll just do this. So I'm actually going to create another function called same character. It's going to pass another string. So what we're going to do is we're going to loop through. If s at I is not equal to s at I plus 1. So if it's not equal to the right side, then we know it's false. Then we know it's not the same character, right? So then we're going to return false. Like if it's not equal to the one on the right side, the one right next to it, we return false, right? Otherwise, by the end of the loop, it's going to return true. Okay, so that is going to deal with having the same character. So now what we're going to do is that we're going to check if the first part are all the same characters. Maybe I should call the function all same. So all same characters. Okay. So if the first part is all same character, then let's recursively call on the second string. We're going to return if the second string is good. So if the second string, we're going to pass in the second part of the string, check if it's good, right? If the second, otherwise, if the second part of the string is all the same character, then we're going to return if the first part of the string is good. Okay, so that will help us do that part. Okay. So here's a catch. Okay, so here what we're doing is that, remember, based on this definition, a good string is that the first half of the string contains only the same character, and then the second half is also a good string, right? So now what they do here is that now we're going to look at the second half of the string. We're going to call the same recursive call. Is CD a good string? CD BB a good string? Yes, it is, because BB is the same characters, right? And then CD, they recursively call on CD, right, to check if that's a good string. So on the first part, the first half, to see if that's a good string. So they call that, and now they split the CD into half, so C and D, and because they're only single characters, they are a good string. So what we're going to do is we're going to, if the size ends up getting down to one character, we're going to return true no matter what, right? If the first and the second one are both one characters, we're going to return true no matter what. So that's going to be our base case at the end. So that's what we're doing here. So yeah, so this time, at this point, let's say we're splitting down halves every single time, and now the first and second is going to be single characters, so we have to check that. So if first and second, if the first size, the size of the first half is equal to 1, that's a single character, right? If this size is a single character and the second size also a single character, then we're going to return true. Okay, because at that point, that's the last basic part you could have. That's a good string. It's a single character, so that's a good string. Okay, so that I think that will fix most of the base case issues. Okay, so that'll fix that part. Otherwise we're here. Okay, so if the string, first string is correct, so call it second of course call first. Okay, so after this we're just going to return false if they're not the same characters as one, right? So at this point, return false. Okay, so let's see. If all the same characters first, we'll return is good on second. Otherwise, if all the same characters second, we're gonna return is good on first. Otherwise, we're gonna return false because then it's not a good same character. Okay, so yeah, so is good. Ideally, this should work. If I screwed up, it could cause a Stack Overflow. So let's call is good on string s, and then we're gonna print out this. So now, yeah. So let's now input a test case. So now let's run it. So now we're gonna input. So let's input one test case. Now we're gonna input a string. So let's input any string. Let's see. They did their string was this BBCD. So let's input this. So you have to input the length also because you're reading the length. So we're gonna read in 8, and then we're also gonna read in BBDCAAA. So that's what we're gonna do here. So yeah. Okay. Okay. So whoops. Okay. So 0 is in C++. 0 is false. So this actually returned false. So that's actually not good. So there's one issue. I think there's an issue with our code here. Okay, let's actually try this again. So I'm actually gonna comment out this part. Let's comment out the first part. I'm gonna pass in an actual string of BBCDAAA. Okay. Why can't I do that? Oh, whoops. Okay, so I have to actually create a string. Let's be BBCDAAA. Now I'm gonna pass that in here. Okay. All right. Now I'm gonna debug it so that I don't have to run it over and over again. Let's see what issue we encountered, and then let's break. Okay, so let's go down deep inside of good. So right now, string first part, string s is right, so that read in. The first half should be BBCD, so that's right. Second half should be AAA, that's right. Okay. So now they're not both equal to 1 yet, so that's it. Is all the same characters first? No. So this should return. So let's go in all same character. This should be returned false. Wait, hold up. Yeah, okay, wait. Yeah, okay, so that's gonna return false. So that's right. So it's gonna skip this if statement and go to the second one. Okay, so now we're gonna check if all the same character is second, which it should be. So it's gonna keep running. Whoa. Wait a minute. Why did it return false? Hold up. Okay, it returned false. Something happened. Second one should be all the same characters. Let's see. What did we do wrong? If it's not equal to the next one, what did we do wrong? Hold up. Okay. Okay, we did something wrong. Okay, let's do this again. So this is, wait, yeah, okay, that's right. This one, AAA. The first one is AAA, so it skips that. Second one's AA. I is now 1, so then now I plus 1 is AA, so that does right. I is now 2, so 0, 1, 2. That's right. I is 3, 0, 1, 2, 3. Hold up. That's not right. we need to change our bounds. Let's see. Why is this not right? Size is 4, right? 4, 0, 1, 2, 3. You should only go up to I minus 2, I guess. Hold up. 0, 1, 2, 3. Yeah, we're just gonna do I minus 2. Size minus 2. Okay, this should be, let's try it again. Okay. Still false. What is the problem? Let's go back. Something is just issue. This one shouldn't be that bad. Some basic errors. AAA 0 1 2 3. What is going on? What is s dot size? S's size is 0, 1, 2, 3, 4. Something's not right. Why is this? Oh my gosh. Man, I'm stupid. I am stupid. I didn't do I less than. All right, that's my fault, guys. Okay, this should work now. This should actually work now. So let's do this again. Okay, is all good. Second one. So all A's should. Yeah, returns true. Okay, so that's good. Okay, so now that returns true. So now we're gonna check is good on the first. Is good on the first is gonna split. So it's gonna be BB and then CD. We're gonna check if all of characters on the first. It should be true. Yep, that's true. So now we're gonna return is good on the second one. CD. We're gonna split those by itself. We're gonna check the size. It's true, so it returns true. Okay, so that's a good string. So now after that, it should return true, and that should be a 1. Yeah, so that's a 1. Okay, so that's good. Okay, so that means our function is good, is working. Okay. Okay, so now back to the hard part. We need to now, so if it's good, then we're gonna see out 0, right? Because that's the number of moves that, because if the string's already good, then the number of moves required to obtain a good string is going to be 0 because it already exists, right? We don't have to do any moves, right? Because our job right now is to calculate the number of different moves it takes to replace a character to make sure it becomes a good string. So because it's already a good string, we'll just print out 0. So that helps the first test case. So yeah, so if it's already good, we're going to print out 0. Okay, now here's the tricky part. Okay, so we already used divide and conquer to find if it's a good string or not. Okay, now is the tricky part. What is the minimum number of moves it takes to make it a good string? So this is a tricky part. Okay, so now we have. Let's see what they do here. ASD. So this time, they're inputting a string as ASDFGHJK, and we know this is not a good string. So now, if it's not a good string, what should we do? Let's see. Well, we could replace the first half with whatever character it is. So if I replace the first half with the first character, so like this first half, ASDF, if I replace the first half with all A's of SDF, that'll take three replacements, right? Because I'm going to replace SDF with all A's, and that will take 3 moves. But then I have to do the same thing on the second string. So now on the second string, if I were to replace all the first half with the first character, G, that would take 1 move. right? So then that's going to take 3 plus 1 is 4, right? Then on the fifth, the next half that I'm going to cut it, that's already good because it's already single characters. So I don't know why the output for them minimum number of moves is 7. Why wouldn't it be just 3 plus 1 plus 3 plus 1, 4? They don't even tell you the way to do it. Like, they don't tell you how did they get the number of moves to the second case 7? Oh, wait, we need to obtain an A good string. Okay, A good string means that you're repeating A's, I think. Let's see. A good string is as follows. You're repeating A's, and then there you're going to have... Oh! Okay, I think I get it. So a good string is that you're repeating number of A's, and then the second part you're going to repeat B's, and the third part you're going to repeat a C, and then the fourth part you're going to repeat a D. Okay, I think that's what they mean by a good string. So what we need to do for this part is we're going to replace the first half with all A's. So that's going to be 3 moves. So that's to replace S, D, and F into A's. And the second half, we need to replace the second half, this GH to all B's. So that'll be 3 plus 2, because that'll be 2 more moves, right? Because I'm going to replace G and H to be a B, both B's. So that'll be 3 plus 2, that'll be 5. And then the last half, we need to replace one of them to be a C, and then the other one to be a D. So that'll be 3 plus, so we have 3 moves for A to replace A, 2 moves to replace B, right? So that'll be 3 plus 2, which is 5. And then we have another one move to replace a C, so 5 plus 1 is 6. And then one more move to replace the K to become a D, so that'll be 6 plus 1 is 7. So that's why they get 7 here. Oh, okay, I get it. So in that case, we have to modify our definition of is good or not, because we need to check if it's all A's, then check if the second one's all B's, then check the third one's all C's, and then check the fourth one's all D's. Okay, let's see. Okay. Let's check out the third case. This one, C, E, A, B, B. Why is it 4 moves for that one? Let's look at that one. Before we start coding, let's look at that one. Actually seems like I'm almost running out of time. Oh, what the heck? Why did this clock stop running? Okay, I'll give myself another 15 minutes to try to solve this problem. If I can't solve it, then I'm just going to look at the editorial. Or, I don't know, maybe I should give myself more time, because I feel like I'm going somewhere. I'm landing to a solution. Okay. All right, so we have C, E, A, B, B. Okay, the first half of the string, let's cut the first half. So let's cut this half. These are all A, B, B, so we should replace all the B's with A's, so that'll be 2. Then here we're going to replace okay, so there's 2 choices we have. We could either replace the first half of the string with all A's, or the second half of the string with all A's. In this case, the number of A's we're replacing is going to be the same on both sides. So remember, we're trying to get the minimum number of moves to replace, right? So we need to actually calculate the number by that, do a comparison about that. But anyway, if we replace all of A's on the right side, it's going to be A. So that'll be 2 moves to replace both B's to become A's on the right side. Then over here, we need to replace 2 of these to become B's. So that'll be another 2 moves. So that'll be 4. Wait. Yeah, so this would become 4. B is to become 2 moves to get to go to replace. Wait, no. C. Okay, so we have A. Okay, here we're gonna replace all the values to be A's, so that's 2 moves. Here we're gonna replace the last 2 values to be B's, so that's another 2 moves. 4. Don't we need to replace one for C and D? Replace E. I don't know why the answer is 4. It should be. I think it should be 5, but maybe I'm not getting something. First half of the string is E because a good C. Second half of the string is D is a D good D good string. Another example is a string as follows. Good string. BB consists of only character B's. Second half of CD is a good string. It's a CD. Oh, okay. So we don't actually have to replace the second character because it's a C good string. It's a C good string. It started with C, so that's why it's a C good string. The first half is just C. The next half is a D. So in our case here, we don't actually have to replace the E, right? Because it's already good technically. Technically, it's good. So if we're gonna replace, we'll just replace the last 2 B's to be A's, and then these 2 to become B's. Then we have a C here, and then that's an E, so that's gonna be 4. Let's look at the next test case. B B A A D D C C. Why is it 5? Place the first 2 become A's. Right, the first half to be all A's, so that's 2 replacements. So that's 2. This one we're gonna replace 2 of these. First 2 become B's, and then we already have a C there, so that's fine. And then if it's a C, we're going to replace one of them to be some different character of C, so that'll be D. So that's 2 plus 2. 4 plus 1 is 5, so that gives us 5. Okay, let's look at just single character Z. We just replace it with A, and that's 1 move. 2, we'll just replace one of them to be B, so that gets us 1 move. Okay, so I think I'm starting to understand how to do this. We actually need like a current character that we're calling, and then updating that character, because we first have to replace A's and then B's and C's and D's. So we need to have a character that's going to do that. Yeah. This good might not actually be a good way. Let's see. Because is good is not. They don't just want us to find good. They want us to find a good. Right. So it starts with A, then it goes to B, then C, and then D. Let's see. I'm actually not sure. Okay, so here, if we're going to do a replacement, let's do a for loop. I equals 0, I is less than s dot size, I plus plus. Okay, so we need to check if the first half is all. Oh, damn. This is going to be difficult. If the first half is all A. Oh my gosh. You need to check if there's an A in the first half. Check if there's a B in the second half. Oh no, check if there's an A in the first half, either the first or the second one. If there is, we're going to recursively call pass in B. Then check if there's a B in the first or second half, then do our replacement for B, then recursively call if there's a C in the third half or fourth half. If there's a C, replace the values there, recursively call in the end, so on and so forth. Okay, so that's what we have to do. Let's see. So technically it's going to look similar to this, but let's call it like replace cars. So let's do like a integer, because that's going to return moves. Replace cars characters. Maybe we should do like make good string. I don't know. String s. Okay. It's gonna be similar to this. We need a starting value though. We need a starting string, a starting character. Starting character is gonna start at A, and it's gonna go to B, then C. Because it's gonna be an A, because we're passing an A, I could just add 1. I think you could do that. You could cast it into an integer and then add 1. So yeah, let's do that. Let's do int next letter is going to equal to start string casted to an integer, and then we're going to add 1. So we're going to add 1 to that. So that'll be the next letter. We're going to use this to recursively call during the next function. Yeah, we still need to split into first and second, so let's do that. So first is this, second is this. Okay, now we need to check, does the first half contain a letter? Excuse me. Does the first or the second half? So if first half contains, okay, I'll write it in English first. If first half contains a letter start, then replace all first half with start character. Recursively call on the second half. Okay. Otherwise, we need to check if second contains a letter start. So this is pseudocode. If second contains a letter start, then we're going to replace second half with all start character. Recursively call on first half. Okay, and that's it. Recursively call on recursively call on second half with the next letter. So if we're gonna start with A, does the first one contain A? If it does, we're gonna replace all that with A's. Then recursively call on the second one, second half. If a second one contains A, replace second half with the all A's. Recursively call on the first half, passing in B's. Okay, so with the next letter. Okay, so this algorithm should work. Now we actually have to code this, which is going to be a pain in the butt. I said but. Yeah, that's funny. Okay, wait a minute. This might fail actually, because we need the minimum number of moves. we can't just make it a good string. We want to find the minimum number of moves. So that means we have to check how many A's are in the first half, how many B's are in the second half. Not B's. How many A's are in the first half, how many A's are in the second half. Whichever is the largest number of A's, then we replace the rest of those replacements, right? Because like if I have a string that's like BBDCAAA, right? This second half is all A's, so I don't actually have to do any replacements for the second half, right? So like I shouldn't be replacing all A's for the first half. So I have to compare the number of characters. We need to find the number of A's on the first and second half. Whichever is larger, we'll replace the rest for that. Then we recursively call on the other half. I hope you guys understand what I'm doing. Okay. All right. So. Okay. This is gonna be tough. Okay. Yeah, this is gonna be tough. Let's think about this. This should be a char, by the way. Okay. So first we need to count how many letters contain this in the first half. So I feel like I'm getting there. I'm getting somewhere. I don't actually need this timer. This timer is making me anxious. Let's see. Yes. Yeah. Okay. So we need to count how many. There might be is there a function that does this for us? Let's see. Count number of characters in string in C++. Might be a function that does that. Oh, there's already is one. Okay, so I could do that. Okay, that's actually good. Okay, so we're gonna use this. Count. So, yeah. So, if count. Okay. Okay. So if count. Okay. If count of the first half is greater than this one, the second one, then we recursively call on the second one. Sorry, I was wearing headphones and then that literally blasted my ears. Okay. I don't think we need to read the tutorial yet. I feel like we could solve this. I feel like I'm getting somewhere. Okay. So, if whichever is greater, we're going to replace that character with that number, right? So, like, if the right side has more A's than the left side, I'm going to replace the right side with that number of letters. No. Okay. If the right side, okay, hold up. Let's go back here. So let's say I have this here, this string, BBAADDCC. How many A's are there on the first side? There's 2 of them. How many A's are in the second side? There's 0. How many more moves do I have to take for the first one versus the second one? Right? I want the minimum number of replacements for A's, to replace A's. Second one is going to take 4 moves to replace A's. Right? The first one, because it already has 2 A's, it just takes 2 more replacements for the B's to become all A's on this one, right? So that'll be 2 replacements. So if I want a minimum number of moves, minimum number of replacements, I'd rather replace the first one with all A's than replace the second one with all A's. Right? If I'm replacing the second with all A's, I'll have to have 4 replacements. If I'm replacing the first one with the first half of the string with all A's, that's 2 replacements. 2 is smaller than 4, right? So I need to replace the first string with all A's. Okay? So yeah, that's what we're going to do. So if the number of A's in the first half, so here we're going to have a start character. So let's do this also start character, and then this is going to be second character. So if the number of A's in the first half is greater than the number of A's in the second half, we are going to replace all the first half with A's. Okay? So yeah, we're going to replace all the first half with A's. So there might be a replace function I think I could use. And then we're going to add the count. Okay. I need to create variables because this is actually hurting my brain. Okay. Number of characters first half. It's going to be this. Number of characters in the first half, right? So number of A's in the first half. Number of character in the second half is going to be this. Okay, so if first half is greater than second half, number of characters in A. So first half, if the number of A's in the first half is greater than the number of A's in the second half, we're going to replace the first half with all A's. Okay? So I'm going to do a loop from 0 to s.size, and I'm going to replace all characters of for I equals 0, I is less than s.size over 2, I plus plus, and I'm going to make s at I is going to equal s at I is going to equal to start character, right? So we're replacing all those. Okay. Yeah. Then we need to count the number of moves it takes. So that's going to be, we actually could do it mathematically. We could just take s.size over 2 minus first number of characters in the first half, right? So like, this counts the number of A's in the first half, right? So the number of replacements we need to take would be not this, not A's. That would be the number of replacements that are not A's. To do that, we just take s.size over 2 minus this. So that's going to be our moves. Okay. Okay, so we did that mathematically. Okay. Technically, we don't even need to do this part, but I replaced the moves anyway. I did the moves anyway. Okay. Okay, so now we have that. Now we need to recursively call on the second half. So we're going to do a recursively call on the second half. So we're going to do make good string on the second half of the string. So that's second. Yeah. Second, and then we're going to pass in the next character that we have to make good. So the next character is going to be next character. So what am I doing here? I'm comparing the number of A's in the first half with the number of A's in the second half. Whichever is greater, that'll be the number of times I'm going to replace A, right? Then I'm going to, yeah, that'll be the number of times I'm going to replace A. So like if there's three, let's say there's 3 A's on the left and there's 1 A on the right, then I'm going to replace the minimum number of replacements in the first one is going to be the, I'm going to replace that many on the greater number of A's because that'll be the minimum number of replacements. But the second half, I'm going to recursively call in the second half, and I'm going to replace B's for that. So that's what this next letter does. Okay. And then now we need an else statement. Else if it's the opposite of this one. So this time second half is greater than first half. Then we do our replacements this way. So otherwise we're going to start on the right side, the second string, and replace all those. So we're going to loop from the right half of the string, s.size over 2, I is less than s.size, I plus plus, and we're going to replace all these with start. Okay, I think that would work. Let's see, I start over 2. This should work. Well, let's actually test this. So this is replacing the right half of the string to the same letter. So I'm going to test that actually. So I'm actually going to do that here. Let's just do this in the function main. Let's create a random string G A B C, and then if I do this from G and replace it all with, let's say I replace all with B's, it should give me AABB. That's what it should give me. I gotta comment out this English. Why is it not working? Oh, okay. Yeah, so this should give me AABB. Okay, let's see if this for loop works. Because sometimes I'm bad at indexing. Okay, hold up. What is the problem? Make good should return a value. Oh, let's just return anything. For now, let's return anything. This should give me AABB. ABB. Okay, that's right. Let's try another even string just in case. A, B, C, D. Let's do this. A 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. Yeah. 1, 2, 3, 4, 5, 6. So this should give us the second. This ideally should give the right half to be all B's, right? That's what this should do. So it should be ASD and then all B's. Okay, yeah. So that works. Okay, so that part works. Okay, so now because that works, we continue back to here. Why did I delete it? Yeah, I need it. I need it. Okay. Then we gotta remove these. Okay. Now here, instead of B, I'm gonna replace it with the character. What'd I call it? I call it start. Yeah, our current character. I shouldn't call it start. I should call it like current character. It is what it is. Okay, so that replaces that. Okay, that replaces that. Now we need to cursively call make good string on the first and next character. Yeah, and ideally this should work. This should work. Yeah. So number of moves is the same thing as s dot size minus number of characters per step. So this would be same thing, but this is gonna be second half. Yep. Okay. Now. Okay. Now we have those and we have that. I need to sum up the moves now and return it. So I'm gonna sum up the moves. I should have a variable sum that adds these up, and then it just returns the moves. So yeah, okay, so I need to do that. I'm gonna create a variable called sum moves 0. I'm gonna add each move and then add the corresponding recursive call of moves. So I'm gonna do sum plus equal to this. Sum moves. I'm gonna do sum moves plus equal to moves. Yeah, I'm gonna do the same thing here. So I'll do sum moves plus equal to moves. Sum moves plus equal to make good string. Okay. Once I do that, yeah. I just return moves. Sum moves. Okay, now we need to think about the base case. Okay, so now once all that gibberish was done, base case would be, let's say it goes down all the way to one character. So first, Sega becomes one character. Oh, I didn't even think about if they're equal. If they're equal, then you could just pick the first half, I guess. I don't know. If they're equal, you could just pick arbitrarily any of them. But all right, now let's think about it. What is the number of moves it takes when it gets down to 2 single characters? 1. It'll just be 1. Right? Because yeah, it would just be 1. So if you had zero, zero, let's say there's 0, 0, and then we're replacing B with A, B, B becomes, there's just gonna be 1 A. There'll be 1 move. I don't know where I'm gonna return 1 though. So let's see. So if they're both huge. This is tough. Okay. It's very tough, very tough. Let's see. Average watch time 8. Huh. Okay. Let's see. If there's only 1 string, we need to have when it gets to 1 string, we need to replace one character. So if it goes down to AB, if it goes down to like AC, So okay, let's go back to here. Okay, I replace all A's, replace all B's. Here, all B's are equal, so number of moves is going to be 2 minus number of B's 2, 0. Here, go C, where's the C? C is C, number of Z's, C is 1. C is 1. Number of moves, C1. Oh my gosh. C1 is going to be all ones. B, so this would have C. Then this one would be D. So here, A. Yeah, okay. Maybe it just works right now. I don't know. I don't know if it works or not. It might work, actually. Let's see. Not sure, though. Might just return 0. Make good string of S. Why can't I do that? Oh, the starting character is going to be A. Okay, say 6, 8, B, B, D, C, A. -1. So it returns -1. Why is it returning -1? Let's see. Let's try this one. A, S, D, F, G, H, J, K. 3. Okay, it's starting to make sense. 3. Okay, hold up. Let's see if our next character is actually right. So let's print out start. Six, 8, B, B, D, C, A. So it goes B, then C, then D, then E, then F, then -1. Oh, the E, the F. Okay. All right, so that's right. Okay, so it goes A, B, C, D, E, F. Okay, why is it returning -1 though? Let's see. Okay, why is it returning -1? Should return 0. 6, 8, B, B, D, C, A. So let's go down here. Okay, so this character is fine, but it doesn't matter. First, B, second is A. First hat count should be -1. Should be 0. Second out should be 4. It's not 4 is greater than A, so we're gonna replace. Zero moves 4. Zero. Make good string on the second one. first and second. Number of 0. Number B is 2. Second half is 0. So we're gonna do this for these. Call it, make these all B's. Oh, give me 0. 0. Make good string right half. There's 0. C 0. C is 1. 1. Yeah. Plus moves. Add a good string, I say D. Okay. I get it. This last character should be over here. Okay. If s dot size is equal to 1, we need to check if it is equal to start. If the character is equal to start, the one that we're looking for, then we just return 0. Otherwise, we gotta return 1. Return 0, else return 1. And yeah, that should work. This should ideally work. Six, 8. Still 0. Oh yeah, that's right. That's actually right. Okay, that's actually right. What am I doing? 3. Oh, this gives 7. Why is it? Why? I'm not summing it up correctly. Let's go back. Try it again. We're not summing it up correctly. Lord, mercy on me. Have mercy on my soul. So, I mean... Okay. First half, second half. A's. There's 1 A. Second half 0, so... Place them all with A's. 3 moves, some moves 3 plus equal to make good string. Some moves J, G, H, J, K. Number of moves, nope. 0, love J, K. 0. Oh, fuck. We need to have, if they're both the same, let's just have we replace the first half. Like, you could choose arbitrary. Let's try this again. 1. Okay. So all A's. B's. 2 of them, so that should be 5. JK. C. 7. That's right. I think that's right. Yes, that's right. Okay. Let's try the rest. Let's try the rest and see what it gives us. Let's try the rest. If it gives us bad, then I don't know. We tried our best. We tried our best. All right, 0, 7, 4, 5, 1. Oh, wait, is this 2 or 1? 1 and 1. Okay, that's right. That's right. Okay, I think we got it. I actually think we got it. Okay, I actually think we got it. Okay, let's delete the is good and is all same because we don't need that. Okay, make good. I think we actually got it. Let's submit the code and see what happens. Okay, wrong answer on 2. What's the problem? Fourth numbers differ. Expected 1, found 2. Fourth 1, 2, 3, 4. 2 BU. Let's see, 2 BU. Two. BA is 2, BU is 2. Let's see, real answer. BA. Zero, 1, 0, 1. Let's see, 0, 1. Zero, 1, 0, 2. Let's see, this one, 0, 1, 0, 1. So the fourth one should be a 1. 1, 2, 1, 2, 3, 4. BU should be a 1. Why is BU? We're almost there. Okay. Let's see. Make it A. Number move should be 1. Maybe you have to return 0 all the time. Maybe we don't need this. Maybe we just return 0. I don't know. I don't know how it works. I mean, I do know how it works. I just don't know. I don't know if the code is right or not. Okay, now it's a little, now it's off. Okay. You do have to return 1. Maybe you just always return 1. No, that's not right. You have to return 0 if it's already... Do we know it's already good? Ah, this base case is killing me. B if it's already A. It's equal to start, then you gotta return 0. Oh, let's return 1. Oh, this big thing is killing me. Ah. Oh my gosh, if we break it down to simple C and D. So the issue here is that when you get to the last character, BU, it replaces BU with A, and then it should stop, because the second part doesn't matter, right? So, however, if it's not that, it's like C. Wait, hold up. Let me see something. We can do A 3 BB 2. How'd you get 7? Oh, we gotta change this to BC. But if it's just 2 K letters, you just need to change 1 from B. So, yeah, okay. We're gonna keep this in our recursive call. If s dot size second is equal to 2, then we just return now I'm trying to figure this out. How you doing? How you doing, guys? I'm trying to figure out this problem. Let's divide and conquer. D, a good string, 656. I'm doing well. Very well right now. How are you guys doing in the chat? Here's the thing is that I don't know why this, so they place 3 A's, then 2 B's, then 1 C, so that would be 3 plus 2, 5, plus 1, 6. Oh, okay. I don't even need a recursive call. For that certain case, that small case, I could just do a if statement in the beginning. So if S is equal to 1, equal to 2, Check if it has no count s dot size s dot begin s dot end pass in a if it's equal to 0. Then cout 1. Else we'll call our make good string. Okay, that's just that one scenario. For some reason that I'm not passing. There's a hacky way to do it. I'll look at the editorial afterwards to make my code better. But I think this would work. The wrong answer on 1 now. Why? Why? What am I doing wrong? Zero 7 4 5 1. 2 AC should be put this here. Easy. Okay. Still wrong answer. Alright guys, I think it's time to look at the editorial. Why am I still getting wrong answer? Pretty sure I did this recursively right. What am I doing wrong? Fifth answer differ. Expected 2, found 1. What's the fifth answer? GP. I don't get it. Why does GP has 2, but BU has 1? Tell me why. Tell me why. Someone tell me why. Oh, because there's already a B. There's already a B in the first one. The second one, there is no B. Wow. Wow. Let's look at that then. We'll do this. If the count of A is equal to 0, or the count of B is equal to 1, then we print out. Oh, if the count of A is equal to 0, and the count of B is equal to 0, then we print out everything. So we do the same thing. Let's do the same thing here. Is equal to 0. Okay. Okay. Let's see if this works now. Still wrong answer. What am I getting wrong? Fourth number is different. Expected 1, found 2. BU expects 1 but found 2. Oh, or. I need an or here. False. False should give us false. Oh, equals to 1. True, so this would be false. True, false, true, equals 1. Should work now. I pray it works. If it doesn't work, then I'm gonna cry. Actually, I don't know. I'm not gonna cry. I'll cry on my soul. So wrong. Why? Why is it not working? Alright, guys, I'm gonna head out now. I'm pretty tired. I'm gonna end the live stream now. Rate, comment, subscribe. I'll check you guys later. I'll figure out this problem.